Tornado reports are already coming in across the plains, but the next round may be the one that decides how dangerous this setup becomes. The first reports tell us the atmosphere is already capable of producing tornadic storms, but this system is still unfolding, and the focus is now tightening across central and northeast Kansas, southeast Nebraska, far northwest Missouri, Iowa, and the wider mid-Missouri Valley. The Storm Prediction Center has placed part of that corridor under a moderate risk. Forecasters are watching for numerous severe thunderstorms, with some supercells capable of very large to giant hail and multiple strong to intense tornadoes. That is serious language. But the bigger concern is the timing. NWS Kansas City says storms are very likely late Monday evening into early Tuesday morning, with hail, damaging winds, tornadoes, and heavy rain all possible. A flood watch is already in effect for parts of north-central Missouri and northeastern Kansas, and stronger storms could drop rain at 1 to 2 inches per hour, with higher amounts in spots. So this is not only about whether tornadoes form, it is about whether storms organize after dark, whether they stay separated long enough to rotate, and whether tornado warnings, damaging winds, giant hail, and flash flooding begin overlapping in the same overnight window. The first reports were the warning sign. The next round is the real test. If this is your first time here, welcome. This channel is built for real weather breakdowns, not panic, not empty fear, not recycled headlines. By the end of this video, you'll understand why the next round matters more than the first tornado reports, and what forecasters are watching as night approaches. If you're in Kansas, Nebraska, Missouri, Iowa, or anywhere near this corridor, comment where you're watching from and what conditions look like near you. Subscribe if you want grounded weather and climate crisis coverage built on facts, not hype. Part 1. The reports were only the first warning. The first tornado reports are already on the board, but this is not the part forecasters are watching most closely. That may sound strange because tornado reports usually feel like the main event. Once a tornado is reported, the mind naturally goes there first. Where did it touch down? How strong was it? How much damage did it cause? Who was in the path? Those questions matter, but in this case, they are only the beginning of the story. Preliminary tornado reports have already been logged from Florida, Nebraska, Kansas, Minnesota, and Iowa. That spread alone tells us the atmosphere has been active across a wide area. It also tells us this is not a quiet, severe weather day waiting to begin. It is already showing what it can do. But early tornado reports are not the same thing as a final record of what happened. They are first signals. They can come from spotters, radar indications, local officials, emergency managers, or public reports. The final count, the final damage tracks, the width, the length, the intensity, and the EF ratings come later, after survey teams go into the field and examine the damage. So the early reports matter, but they do not close the case. They open it. The larger concern is now shifting into the next severe weather corridor, central and northeast Kansas, southeast Nebraska, Iowa, and northwest Missouri. Within that zone, parts of central and northeast Kansas, southeast Nebraska, and far northwest Missouri are under a moderate risk from the Storm Prediction Center. That is a major signal. It does not mean every town inside the risk area will see a tornado. It does not mean the worst outcome is guaranteed. But it does mean the setup has moved beyond ordinary spring thunderstorm language. The Storm Prediction Center expects numerous severe thunderstorms across the south-central plains and the mid-Missouri Valley. Some of those storms may become supercells, the rotating kind of thunderstorms that can produce very large hail, damaging winds, and tornadoes if the ingredients line up correctly. And the hail threat is not small. The outlook includes very large to giant hail. That matters because hail of that size tells you the updrafts inside these storms may be powerful. A storm strong enough to suspend and grow large hail is a storm with serious internal energy. Still, the tornado threat depends on details that may not be obvious from the ground. A boundary left behind by earlier storms can become the track where new storms focus. A clearing in the clouds can allow the surface to heat and reload the atmosphere. A storm that remains isolated can rotate more cleanly than one that immediately gets swallowed up into a messy line. That is why the next round matters. The first tornado reports are like hearing glass crack before a storm slams into a window. The crack tells you pressure is already building. It tells you the structure is under stress, but it does not tell you the worst push has already passed. For people across the plains, this is not just a map with colored risk zones. It is the phone on the table, the radar app refreshing, the sky getting darker, the question of whether the next alert comes before sunset or after it. In central Kansas, it may mean preparing for giant hail before the strongest storms arrive. In southeast Nebraska, it may mean checking shelter space before the line of storms builds. In northwest Missouri, it may mean watching both tornado risk and flash flooding at the same time. In Iowa, it may mean realizing the storm that looks distant now could become part of the overnight threat later. The first reports already show the atmosphere can produce severe storms, but they do not show that the atmosphere is finished. The next question is not whether severe weather is possible. That has already been answered. The deeper question is why the next round may organize differently, and why the shape of those storms after dark could decide what kind of night this becomes. The danger may change shape after dark. The danger may not peak when the first storm appears, it may peak when the storm changes shape. That is the part of this setup that can be easy to miss. People tend to think of severe weather as a simple line. Storm forms, storm strengthens, storm passes, danger ends. But plains severe weather does not always behave that cleanly. Sometimes the most important moment is not when storms begin, it is when they reorganize. The Storm Prediction Center is watching for supercells capable of very large to giant hail and multiple strong to intense tornadoes. A supercell is not just a thunderstorm with lightning, it is a storm with a rotating updraft, a storm that can build its own internal engine. When that rotation stays organized, the storm can become more dangerous than an ordinary cluster of rain and thunder. But there is another part of the forecast that matters just as much. The Storm Prediction Center also says quick upscale growth is likely by mid to late evening. That phrase sounds technical, but the idea is simple. Individual storms may begin separately, then merge into a larger line or storm complex. At first, one storm may stand alone, feeding on warm, moist air around it. Then more storms fire nearby. Their cold pools spread, their rain shields collide, their wind fields connect. What began as separate cells can become one larger moving system. That change can alter the threat. When storms are separated, a supercell can sometimes stay cleaner. It has more room to pull in warm, moist air. Its rotation can become easier to maintain. That is often when the stronger tornado threat becomes more focused. But when storms merge into a line, the danger does not simply turn off. It changes form. A storm line can still produce tornadoes. Some may form inside a QLCS, which means a quasi-linear convective system, a line or broken line of storms that can hide small areas of rotation inside it. Others can come from embedded supercells, which are rotating storm structures buried inside a larger storm mass. That is one of the reasons overnight severe weather can become so difficult. The radar may show a broader line. The sky may just look like wind, rain, and lightning, but inside that larger structure, smaller pockets of rotation can still develop quickly. A single spinning blade is dangerous because you can see it clearly, but if that blade gets hidden inside a moving wall, the danger becomes harder to track. That is the concern with storm mode tonight. If storms stay discrete or semi-discrete longer, the stronger tornado threat may sharpen. If they merge faster, the event may shift toward damaging winds, embedded tornadoes, hail, and heavy rain. Neither version is harmless. They are just dangerous in different ways. For someone at home, that difference may never sound neat. The alerts may not arrive with a perfect explanation of storm structure. They may come as one severe thunderstorm warning, then a tornado warning, then a flash flood warning, then another alert as the line pushes closer. The storm may not look like one dramatic tornado on the horizon. It may look like a wall of rain, then hail, then wind, then the phone lighting up again. That is where the confusion begins. If a storm is isolated, people may know exactly which cell to watch. If storms merge into a larger system, the threat can become broader, faster, and harder to separate. The tornado threat may not disappear, it may become embedded. The wind threat may expand, rain may start repeating over the same places, and once darkness falls, the atmosphere does not need to look dramatic to be dangerous. That is why the next round is not only about whether storms form, it's about their shape. Do they stay separated? Do they rotate cleanly? Do they merge quickly? Does the line build before the strongest tornado window can fully mature? Or does the atmosphere allow several storms to stay dangerous long enough before that transition happens? Those answers matter because each version creates a different kind of night. A discrete supercell can put one town in a high-stakes tornado warning. A storm line can spread damaging winds across a wider area. Embedded rotation can create fast spin-up tornadoes with less warning time. Training storms can turn the flood threat into a second emergency. That is the hidden pattern behind the forecast language. The next round could be worse not because every storm becomes violent, but because the hazard may evolve as the night unfolds. What begins as a tornado and hail setup can become a wind, embedded tornado and flood setup. And for people in the corridor, that shift can happen while most of the region is already moving into darkness. So the next question is not just what the storms will do, it is what the atmosphere underneath them is preparing to give them. Because storm shape doesn't change by magic, it changes when the ingredients below it line up. And that's where the setup becomes even more important. Part 3. The ingredients that decide the next round. The next round does not become dangerous by accident. It needs the atmosphere to assemble the right pieces in the right order. A tornado-producing storm is not created by one ingredient. It is not just warm air. It is not just wind. It is not just moisture. It is the combination and the timing of that combination that decides whether a thunderstorm stays ordinary or becomes organized enough to rotate. The Storm Prediction Center is watching several pieces at once. One of them is low-level shear. That means the wind is changing speed or direction close to the ground. When winds near the surface blow one way and winds a little higher up blow faster or from a different direction, the lower atmosphere starts carrying spin. A storm can tilt that spin upward and stretch it. If the storm is strong enough, that rotation can tighten. Another piece is the low-level jet. That is a ribbon of faster air moving through the lower atmosphere. It can feed storms with moisture, speed, and rotation. When the low-level jet strengthens after sunset, storms do not always weaken just because the sun goes down. In some setups, the night can actually improve the wind environment for tornado-producing storms. That is part of why the timing matters so much here. SPC is watching increasing low-level shear late in the day and into the evening. A strengthening southerly low-level jet may enhance the tornado environment. That does not guarantee tornadoes, but it does mean the atmosphere may become more supportive at the exact time people are losing visibility and winding down for the night. Then there's instability. One term forecasters use is MLCAPE, Mixed Layer Convective Available Potential Energy. The name is ugly, but the meaning is simple. It's fuel. It measures how much energy air parcels can use to rise. The more fuel available, the more explosive storm growth can become, if a storm can tap into it. But fuel alone is not enough. There also needs to be a trigger. That trigger may come from a dry line, a boundary separating dry air from moist air. It may come from an outflow boundary, which is leftover cooler air pushed out by earlier thunderstorms. These boundaries can act like invisible roads where new storms form and intensify. That is why morning storms matter. They can disrupt the environment by leaving clouds, rain-cooled air, and lower instability behind. But they can also leave boundaries that later storms use as a focus point. One round can weaken the next round in one location while sharpening it somewhere nearby. That's the frustrating part of plain severe weather. Earlier storms can both interfere with the setup and help define it. SPC expects storm initiation around 18 to 22 Z across central and northeast Kansas into far southeast Nebraska. That means the first key development window is not just about storms appearing on radar, it's about where they appear, what they latch onto, and whether they stay organized. Initial supercells may produce 2 to 4 inch hail, or even larger. Hail that size is not just a property damage problem, it's also a signal that the storm updrafts may be intense. A storm that can keep large hailstones suspended long enough to grow is not a weak storm. It has strength inside it. But the strongest tornado corridor is still not pinned down to the county level. That depends on recovery. If clouds linger too long, some areas may not heat enough. If earlier storms leave too much stable air behind, the atmosphere may be less explosive there. If the boundary sets up farther north or south than expected, the highest risk corridor can shift. If storms merge too quickly, the cleaner, strong tornado threat may be shortened. The atmosphere is like a loaded engine. Instability is the fuel. The dry lime is the spark. The low-level jet is the fuel pump. Wind shear is the twisting force that can turn a storm into something rotating. But all of those parts have to work together. A full tank doesn't matter if there's no spark. A spark doesn't matter if the engine is flooded. Rotation doesn't matter much if the storm can't stay organized enough to use it. That is why one town can get a rotating supercell, while another county nearby gets mostly rain and wind. From the ground, the difference may seem random. One place gets hailstones big enough to damage vehicles, another gets wind, another gets a tornado warning, another gets rain over and over until roads begin to flood. But to the atmosphere, those differences are often written by boundaries, timing, instability, and storm mode. Small details become large consequences. A line of clouds breaks in one county but not another. A boundary stalls near one highway instead of 20 miles south. A storm fires a little earlier than expected. Another storm stays alone for 30 extra minutes before it merges. Those are the kinds of details that decide whether the next round becomes mainly a hail and wind event or whether a focused tornado corridor develops before the storms grow into something larger. For people watching the sky, none of this is visible in a simple way. You can't stand in your yard and see low-level shear. You can't look at a field and know the exact MLCAPE value. You can't always feel the outflow boundary that may become the track for the next storm. But you can feel the pressure of the waiting. You can see the sky holding. You can see clouds breaking in one direction and thickening in another. You can watch radar as storms begin to build along a line that wasn't there an hour before. You can hear the alert tone and realize the atmosphere has moved from potential to action. That's where this setup is heading. The ingredients are not just numbers on a forecast page. They're the machinery underneath the next round.
And if that machinery lines up after dark, the threat becomes more than a scientific setup. It becomes a human problem. Because people don't experience wind shear, MLCAPE, dry lines, or low-level jets. They experience sirens, dark roads, hail hitting windows, floodwater crossing pavement, and decisions that have to be made in minutes.
Part 4. The hardest time to warn people is after dark. The atmosphere may be dangerous, but the human problem begins when the warning comes after dark. That is where this setup becomes more than a forecast discussion. During the day, people can look outside and read the sky in a rough, human way. They can see clouds building. They can see the horizon changing. They can notice the air turning strange before a storm arrives. At night, that advantage disappears. NWS Kansas City says storms are very likely late Monday evening into early Tuesday morning, not possible in some vague future window, very likely. And with those storms, all hazards are on the table: hail, damaging wind, tornadoes, and heavy rain that could lead to flooding. That combination is what makes the overnight timing so important. A tornado warning after dark is already harder to process. People may be asleep, phones may be on silent, sirens may be muffled by rain and wind. The storm itself may be invisible until it is close. You cannot always look west and see the shape of the danger coming. Now add hail. Large hail hitting a roof at night does not just sound loud, it can drown out everything else. It can make a warning feel chaotic. It can shatter windows, damage vehicles, and make people hesitate when they need to move quickly to a safer room. Now add damaging wind. Wind can knock out power before people fully understand what warning they are under. Once the lights go out, the house feels different. The radar app may still work for a while, but the room is dark. The rain is loud. The alerts are coming fast. Now add flooding. A flood watch is already in effect through 10 a.m. Tuesday for parts of north-central Missouri and northeastern Kansas. Stronger storms could produce rainfall rates of 1 to 2 inches per hour, with higher amounts in some places. That kind of rain can overwhelm drainage quickly, especially if storms repeat over the same area. This is where the danger becomes complicated. A tornado warning tells you to get low, get inside, and stay away from windows. A flash flood threat tells you not to drive into water, not to cross flooded roads, and not to assume the route outside is safe. When those threats overlap at night, people can be forced into decisions with very little time and very little visibility. Imagine a family hearing a tornado warning after midnight. Rain is already pounding the roof. Hail is hitting the windows. The power flickers once, then again. Someone checks the phone and sees the warning polygon. Someone else looks outside and sees nothing but water running along the curb. The safest place for the tornado may be the lowest interior room, but the wider storm environment may also be producing heavy rain and rising water nearby. That is the kind of overlap that risk maps cannot fully capture. Daytime storms are like seeing a wave coming toward shore. Overnight storms are like hearing the water rise in the dark and trying to guess which direction it is moving. And it is not only one household. Across the corridor, people may be dealing with alerts that arrive in layers. A severe thunderstorm warning, then a tornado warning, then a flood advisory or flash flood warning, then another severe warning down the line. If storms keep training over the same places, the alerts can begin to feel relentless. That is warning fatigue. It doesn't mean people don't care. It means the brain gets overloaded. Too many alerts. Too many sounds, too many changing threats. After the third or fourth warning, some people start waiting for a clearer sign before they act. At night, that hesitation can become dangerous.
The actual impacts are still not fully known. We do not yet know which roads may close, where power outages may occur, whether rescues become necessary, or where tornado and flood warnings may overlap most sharply. But the ingredients for a difficult response window are already clear. This is why the timing matters so much. The threat is not only what the storm can do, it is whether people can understand it quickly enough, respond safely enough, and make the right decision while the sky is dark, the roads are wet, and the warnings are changing. That brings the story to the hardest line to walk: how serious this could become, what is most likely, and what should not be overstated.
Part 5. The ceiling is serious, but it is not a guarantee. The most serious outcome is not the forecast, but it is the reason forecasters are watching the next round so closely. That distinction matters. The most likely outcome is already enough to take seriously: a significant severe weather episode across the Central Plains into the mid and lower Missouri Valley, with large to giant hail, damaging winds, some tornadoes, and localized flash flooding. That alone is not a routine night. Large hail can damage vehicles, roofs, windows, and crops. Damaging winds can bring down trees and power lines. Some tornadoes may occur. Heavy rain may fall fast enough to flood roads and low-lying areas, especially where storms repeat. That is the grounded expectation, but there is a higher ceiling if the atmosphere lines up in the wrong way. If the warm sector recovers enough after earlier storms, if boundaries focus new development in the right corridor, if low-level shear strengthens at the right time, and if discrete or semi-discrete supercells last long enough before merging, the tornado threat could become more focused. That is where the stronger language from forecasters comes in. The strongest tornado concern is tied to central Kansas, southeast Nebraska, Iowa, and northwest Missouri. SPC has already highlighted the possibility of multiple strong to intense tornadoes. But possible is not the same as guaranteed. That depends on how the storms actually form and behave. A forecast like this is not a locked door already standing open. It is a row of locks. Recovery is one lock. Boundary placement is another. Storm mode is another. Low-level shear is another. Timing is another. If enough of them click into place, the ceiling rises quickly. If one or two fail, the event can still be dangerous, but the highest-end tornado threat may stay more limited. That is why the details matter. If storms merge too quickly, the cleaner, strong tornado threat may be cut short, but damaging winds and embedded tornadoes can still become a problem. If clouds and morning storms limit instability, some areas may not reload as strongly. If the boundary shifts, the highest risk corridor may shift with it. And if storms train over the same counties while severe warnings are active, flooding becomes more than a side issue. WPC has a moderate risk for excessive rainfall, and NWS Kansas City expects heavy rain with the stronger storms. That means the event doesn't need a long-track tornado to become dangerous. A night of repeated warnings, hail, wind, and flooded roads can create its own emergency. For people in the corridor, this distinction matters because they do not need hype. They need clarity. They need to know the event is serious but not predetermined. They need to know strong tornadoes are possible, but no one can assign final EF ratings before storms happen and survey teams inspect damage. They need to know the most intense outcome depends on ingredients still coming together in real time.
The exact tornado max corridor is not fully settled. The final tornado count is not known. The final damage picture is not known. How long supercells remain separated before merging is still one of the key questions. But waiting for certainty is not how severe weather risk works. The safer way to understand this setup is simple. The atmosphere has already shown it can produce tornado reports, and the next round has enough support to become more organized, more dangerous, and more complicated after dark. So the final question is not whether the story is dramatic enough. The final question is what signals will tell us which version of the event is unfolding. Part 6. The window that decides everything. The next few hours are not just forecast time, they are decision time. This is the part of the setup where the maps start handing the story over to radar, watches, warnings, and storm reports. The ingredients are already there. The corridor is already being watched. The first tornado reports are already on the board. But the atmosphere still has to show which version of this event is actually unfolding. The key window is late Monday evening into early Tuesday morning. That is when the next round matters most. It is also when people are more likely to be tired, less alert, and less able to see what is coming. The storms do not need daylight to organize. If the low-level jet strengthens, if boundaries hold in the wrong place, and if storms remain separated long enough, the tornado threat can sharpen. If they merge quickly, the threat may shift into damaging winds, embedded tornadoes, and flooding rain. This is why the next updates matter. Watch the Storm Prediction Center outlooks. If the language around tornado potential changes, that matters. Watch for mesoscale discussions, because those are often the moments when forecasters narrow the focus and explain what they are seeing in real time. Watch for tornado watches, especially any stronger wording that suggests a higher-end tornado environment. Also watch storm initiation. The development window around 18 to 22Z is important because the first storms will tell us a lot. Where do they form? Do they fire along the dry line? Do they ride an old outflow boundary? Do they stay isolated, or do they quickly crowd into a line? A storm that stays alone has a different ceiling than a storm that gets swallowed into a messy cluster. Then watch the low-level jet. That ribbon of faster air near the ground can feed storms after sunset. It can increase low-level shear, and that shear is one of the ingredients that help storms rotate. If the jet strengthens while storms are still organized, the night can become more dangerous. Radar will also matter, not just whether storms are there, but what shape they take. A clean, rotating supercell carries one kind of threat. A fast-moving line carries another. Embedded rotation inside a larger complex can be harder to see from the ground and harder for people to mentally separate from ordinary wind and rain. And then there is the flood side. Watch rainfall rates. Watch whether storms train over the same counties. Watch river gauges. Watch flash flood warnings. Heavy rain at 1 to 2 inches per hour can create problems quickly, especially where the ground and drainage systems are already under pressure. For anyone in the affected corridor, the practical message is simple. Do not wait for perfect certainty. Severe weather often becomes dangerous in the gap between possible and happening now. That gap can be short. A storm can go from a cell on radar to a warned storm quickly. A road can go from wet to covered in water before a driver realizes how deep it is. A quiet phone can become the only warning that matters. A forecast is the blueprint. The observation window is the construction site. You don't know what is really being built until the pieces start moving. And tonight, the pieces are still moving. Tornado reports were the visible warning. The real story was always the next round.
So here is where the setup stands. Tornado reports have already been logged across multiple states, including parts of the Plains and Midwest. The Storm Prediction Center has placed parts of central and northeast Kansas, southeast Nebraska, and far northwest Missouri under a moderate risk. Forecasters are watching for numerous severe storms across the south-central plains and mid-Missouri Valley, with the potential for very large to giant hail, damaging winds, and strong tornadoes if the right storms form in the right corridor. But this is not only a tornado story. The next round is expected during a difficult window, late Monday evening into early Tuesday morning. That timing matters because it overlaps with darkness, reduced visibility, sleeping households, and faster decision-making. NWS Kansas City has warned that all hazards are possible, including hail, damaging winds, tornadoes, and heavy rain that could lead to flooding. The most likely outcome is a significant severe weather episode with some tornadoes, damaging winds, large hail, and localized flash flooding. That is already serious enough. The higher-end outcome depends on the atmosphere lining up more precisely. If recovery is strong enough, if boundaries focus storms in the wrong corridor, if low-level shear increases at the right time, and if supercells stay discrete long enough before merging, the tornado ceiling could rise. But that is still conditional. It is not a guarantee, and it should not be treated like one. What remains unclear is the exact tornado max corridor, how long the strongest storm mode lasts, where flooding overlaps with severe warnings, and what the final damage picture looks like after survey teams go out. That is why the next observation window matters. Watch the watches, watch the radar, watch the storm mode, watch the rainfall rates, watch the warnings after dark. And if you are in Kansas, Nebraska, Missouri, Iowa, or anywhere near this corridor, drop a field report in the comments, your location, whether storms have reached you, and what you are seeing: hail, wind, flooding, power issues, or warning activity. Keep it factual, keep it useful. Those ground reports can help others understand what the maps alone cannot show. This channel will keep following serious weather and climate signals without the noise. If that is the kind of coverage you want, subscribe and stay with us. For now, the atmosphere has already given the first warning. The next round will tell us how much more it has left.